When you look out your window and see a car parked in the driveway, your brain automatically categorizes it as just one thing, right? It's transportation.
Yeah, exactly. A machine that's, well, designed to just sit there idle until you need to get from point A to point B.
Right, which means it's essentially it's a stranded asset for about 95% of its life.
Yep, 95%. Just taking up space.
But today, we are asking you to completely shatter that mental model. Because right now, in 2026, there is this massive shift happening that is fundamentally changing the very definition of a vehicle.
It really is. It's a total paradigm shift.
Like, what if you looked at that same driveway and you didn't see a car, but instead you saw a power plant? A literal load-bearing pillar of the national energy grid. Welcome to the deep dive. Our mission today is to give you the ultimate shortcut to understanding the future of energy, minus, all the dense engineering jargon.
And to do that, we are pulling from a really fascinating stack of sources today. We're diving into a forward-looking 2026 industry predictions report from Drives. We are also unpacking a pretty major policy update straight from the U.S. Department of Transportation.
Yeah, that DOT update is wild.
It is. And we are grounding all of this in some incredibly data-rich and honestly kind of sobering presentations from the California Public Utilities Commission. Specifically, this is from their Vehicle Grid Integration Forum.
Right. So we are going to connect the dots here between the physical metal chargers going into the ground, the just staggering economics of the power grid, and the government policies that are forcing it all to happen at breakneck speed. But to understand the grid, I think we have to start with the physical hardware, the plugs themselves. Because the hardware is getting a massive overhaul this year.
It is. The sheer scale of power being delivered to vehicles right now is totally transforming. According to the Drives data, ultra-fast charging is officially mainstream.
Mainstream. Okay.
Yeah, we are looking at 350 kilowatt chargers becoming the new standard. And, just to put that kind of voltage in perspective, a 350 kilowatt charger can get a massive EV battery to an 80% charge in just 15 to 20 minutes.
Wow. 15 minutes.
Yeah. And the Drives report notes that over in the European Union, about 20% of all ultra-fast chargers are already hitting this 350 kilowatt threshold.
That is just pushing a wild amount of power through a cable. And here in the U.S., the Department of Transportation just dropped this major policy mandate regarding who's actually allowed to build those massive chargers.
Right, the new waiver.
Yeah. Transportation Secretary Sean P. Duffy announced an update to the Buy America waiver for any federally funded EV chargers. He is raising the domestic content requirement from 55% all the way up to 100%.
Now, looking at the DOT announcement, we should probably mention there is a ton of really sharp partisan rhetoric flying around right now about, the previous administration's rollout and its alleged failures.
Oh, absolutely. And we want to be super clear with you listening. We are taking zero political sides here. We're not endorsing any of that rhetoric.
Exactly. We're strictly looking at the mechanical goals of the policy itself.
Right. And mechanically, the mandate is hyper-focused on three things: boosting domestic manufacturing, generating American jobs, and addressing severe national security vulnerabilities.
The last point about security is the one that really stands out to me. When you network millions of high-voltage machines to the national grid, having foreign-made components like microchips or networking software, it creates a massive cybersecurity target.
Because a backdoor in those chargers could theoretically give a bad actor the ability to just disrupt the whole power grid.
Exactly. But looking at the mechanism of how the government is actually forcing this change, it is incredibly aggressive.
Oh, yeah. The Federal Highway Administration essentially acknowledged that industry groups came to them and said they needed more time to ramp up domestic factories, and the government basically said, too bad we're doing it now.
Yeah, the FHWA explicitly describes this as a strong incentive to rapidly shift supply chains. It's designed as a shock to the system.
A shock is right.
It is a forced mechanism to make manufacturers figure out entirely new sources for steel, the enclosures, the internal electronics, and they have to do it immediately, rather than letting the market sort of transition comfortably over a decade.
It kind of feels like they are asking the industry to swap out the engine of an airplane while it's in mid-flight.
Yeah.
Like you're trying to massively scale up these 350 kilowatt stations to meet this huge consumer demand, and you have to rebuild your entire foundational supply chain from scratch at the exact same second.
Right.
It's like being told to bake a cake, but suddenly you have to grow your own wheat and mine your own salt first. The friction there has to be monumental for manufacturers.
It is a massive bottleneck, no doubt.
Mm.
But figuring out where the copper and the microchips come from is actually just the preliminary hurdle.
Wait, there's a bigger hurdle.
Oh yeah, the existential crisis. The one that really has utility executives panicking behind closed doors is what happens when you take millions of these 100% American-made 350 kilowatt chargers and you physically plug them into the wall.
Ah. Because delivering that kind of volume requires a grid that was never, ever designed for this much localized demand.
Not even close. The numbers presented at the California Public Utilities Commission's forum are just sobering.
Give me the numbers.
So Pacific Gas and Electric, PG&E, they presented their electrification impact study, mapping out what it will physically take to reach California's electrification goals by 2040. They estimate it will require between $23 billion and $32 billion in distribution grid investments.
Wait, up to $32 billion with the B.
With a B, yes.
Just in California.
That is, I mean, that's almost incomprehensible.
And that is purely for the distribution grid. We are not talking about building massive new nuclear power plants or giant high-voltage transmission towers across the desert. This is the primary and secondary infrastructure.
So local stuff. Right. It means digging up streets to replace neighborhood transformers, upgrading the local substations, and replacing the actual wooden poles and wires in your alleyway. Because they literally cannot carry the amperage required to charge a neighborhood full of EVs.
The scale of that physical infrastructure project is just hard to wrap your head around. But what about the pricing strategies utilities use? I mean, for years, they've used time of use rates, where power is expensive at, say, 6 p.m. and cheap at midnight to incentivize people to charge when the grid is sleeping. Doesn't that sort of solve the problem of overloading the wires?
Well, you would think so, right. But the CPUC forum highlighted this analysis by E3, that's Energy and Environmental Economics, and it revealed a truly fascinating paradox. Those passive time-of-use rates are actually creating brand new, highly destructive problems.
Wait, the fix is causing problems?
Yeah, they are seeing what they call rebound peaks on over 20% of distribution feeders. And just for context, a distribution feeder is simply the main power line branching off a substation to feed a specific cluster of homes or businesses.
Okay, so what actually causes a rebound peak?
Think about human behavior combined with smart technology. Everyone plugs their car in at 6 p.m. after work, right? But the car is programmed to wait for the cheap rate to kick in at exactly 9:00 p.m.
Oh, I see where this is going.
So at 8:59 p.m., the neighborhood is pulling a totally normal amount of power. But at exactly 9:00 p.m., dozens of cars simultaneously trigger their onboard chargers. The local transformer gets hit with an instantaneous massive load spike.
It's exactly like everyone waiting for rush hour to end so they can avoid the heavy highway tolls. But because they all get on the highway at the exact same second, say, 9:01 p.m., they create an even worse traffic jam just later in the night.
That rush hour analogy perfectly captures the disconnect.
It's wild. The utility's own pricing solution is the thing blowing out the local transformers.
Yeah, the bulk system, like the giant power plants, they want you to charge at night when overall regional demand is low. But your local distribution system, that single transformer feeding your cul-de-sac, just cannot handle 10 vehicles all pulling 11 kilowatts at the exact same second.
They're fighting each other.
Completely. The bulk system and the distribution system are totally out of sync. E3's conclusion is that utilities have to abandon these passive pricing tricks and move to active, locationally aware management.
Okay, so if we literally cannot manufacture electrical transformers fast enough to handle these spikes, and we obviously can't afford a $32 billion bill just to replace copper wires, we have to find a way to cheat the system. And looking at the Drive's 2026 predictions report, the industry's answer to this bottleneck seems to be software.
Software and AI. If you cannot build a wider highway, you have to engineer a hyper-intelligent traffic cop. And Drive's predicts artificial intelligence will take on that exact role through dynamic load balancing.
Okay, wait, hold on. I'm going to push back here a bit for everyone listening because we hear AI applied to literally everything these days, from toasters to search engines.
Fair point.
But algorithms are just code, right? They do not generate electricity. If a fleet of 10 electric delivery trucks physically plugs into a depot at 6 p.m. and they all need massive amounts of power, how does an algorithm physically stop the copper wires from melting down?
By perfectly distributing the site's available electrical capacity in real time. Let's say the delivery depot has an electrical panel with a hard physical limit of 100 kilowatts. If all 10 trucks plug in and demand maximum power all at once, they would draw, say, 150 kilowatts.
Which means the breaker trips or the wires literally overheat.
Right. But the AI energy management system monitors that hard constraint. It looks at the real-time grid usage, the forecasted demand, and this is key, the specific departure schedules of those trucks.
Oh, so it's actively rationing the power based on who actually needs it most.
Yes, exactly. It might direct 50 kilowatts to a truck that needs to leave for a shift in an hour, while only trickling a tiny bit of charge to a truck that is parked for the entire weekend. The site never exceeds its 100 kilowatt limit.
That makes a lot of sense.
And this is crucial for commercial operators because it mitigates demand charges.
What's a demand charge?
A ban charge is a pretty punitive fee. Utilities slap on businesses based on their highest single spike in power usage during a billing cycle. By smoothing out those spikes, the AI saves the business an absolute fortune. It also coordinates the charging with any on-site solar panels or battery storage, essentially turning that group of chargers into a synchronized virtual power plant.
Wow. That completely changes the economics for a business owner. But the physical installation of those chargers is still a massive hurdle, right? I mean, the Drive's report points out that the business models are evolving just as fast as the software, specifically highlighting this rise of charging as a service, or COS.
Yeah, cost is huge. Imagine you own a chain of convenience stores, or maybe you manage an apartment building. You know your customers need EV charging, but the upfront capital expenditure, the CapEx, is just terrifying.
Oh, I can imagine.
You have to buy the 350 kilowatt hardware, trench the concrete, upgrade the site's electrical panel, and then panic about maintaining it when it inevitably breaks.
That is a massive financial risk for a business that basically specializes in selling snacks and sodas, not managing high voltage infrastructure.
Right, so charging as a service allows a third-party operator to come in and assume all of that risk. They own, operate, and maintain the infrastructure. The business owner simply pays a predictable operational expense, like a monthly OPEX subscription.
That's a smart shift.
It is. We are also seeing a major push for driver convenience through interoperability.
Thank goodness.
Yeah, these are roaming agreements between different charging networks. So you, the driver, don't need 12 different proprietary apps on your phone just to take a road trip across the state.
The consolidation of apps is such a relief. I hate having a folder of 6 different EV charging apps. The Drive's report also mentions the rise of multi-fuel hubs. Like, for heavy-duty logistics fleets where pure battery weight or charging time is a deal breaker, we are seeing these massive stations that combine ultra-fast EV charging with hydrogen fueling and traditional liquid fuels, all under one single canopy.
It really shows an industry maturing, right? Learning to handle different operational realities. But the concept we really want you to take away from this deep dive, the ultimate game changer that completely rewrites the relationship between the grid and the driver, requires us to stop looking at the vehicle as just a sponge that absorbs power.
Because what happens when we reverse the flow entirely?
Right. We enter the era of vehicle-to-grid, or V2G. It is basically the holy grail of grid management.
Reversing the flow almost sounds like a science fiction concept. Like, you drive to work, you come home, and your car powers your house. But looking at the sources, this is operating in the real world today.
It is. Let's look back to that CPUC forum and PG&E's $32 billion infrastructure problem. PG&E found that if they can implement enhanced demand flexibility, which is a fancy way of saying they rely heavily on V2G to let cars push power back into the local grid during peak hours, they can reduce those distribution upgrade costs by $1.8 billion.
$1.8 billion in hard infrastructure savings just by letting the cars act as local batteries. That's incredible.
And the technology is live right now. Tesla's PowerShare technology is functioning as we speak. The CPUC presentation actually noted that Cybertrucks are currently backing up 5,000 homes.
Wait, hold on. The math on that sounds crazy. One truck isn't running a whole neighborhood, right? How exactly does a Cybertruck back up 5,000 homes?
Well, it's about networking a fleet. You don't have one single truck plugging into a substation.
Yeah.
You have thousands of individual trucks spread across a region.
Ah.
If each truck can output 11 plus kilowatts back into their individual home electrical panels during a grid crisis, that aggregated capacity acts as a distributed virtual power plant. The utility doesn't have to generate power for those 5,000 homes because the trucks are handling it locally.
That is wild.
And the financial incentives are getting incredibly aggressive. Like in Texas, on the ERCOT grid, Tesla has a program where customers actually earn 90% of the real-time electricity price revenues when the grid is stressed, and wholesale prices spike above 30 cents per kilowatt.
Wait, so your car literally becomes a day trader for electricity while you were just sitting on the couch watching television?
Basically, yeah.
It's like finding out the massive swimming pool in your backyard can suddenly function as the municipal water tower during a severe drought, and the city will pay you handsomely for your water. But, I mean, the tech is amazing, but human behavior is messy. How do you actually convince someone listening to this to let a utility drain their car battery right before they might need to go to the grocery store?
That is the big question. The potential is massive, but human behavior and outdated regulations make it incredibly messy to deploy. The CPUC sources highlight a startup called Bidirectional Energy that ran a residential V2G deployment in Oakland, California.
And how did that go?
Well, they successfully proved the software and the hardware work, but the pilot exposed severe friction. Interconnection processes with the utility are agonizingly slow. And on the homeowner's side, older electrical panels often require massive, expensive physical upgrades to legally handle bidirectional power flow. It is far from a simple plug-and-play experience today.
Okay, so the E3 study from the forum lays out the economics of fixing this, describing a delicate balancing act for any large-scale V2G program. They argue a successful program has to thread the needle on 3 distinct pillars. Walk me through this, because the first pillar is that the utility has to procure enough capacity to actually defer grid upgrades.
Right, because a utility doesn't care if just 3 guys in a neighborhood offer up their car batteries.
Yeah.
That tiny amount of power doesn't stop the local transformer from blowing. The utility needs guaranteed, massive scale. They need hundreds of cars on a single distribution feeder to commit to discharging power. Otherwise, the utility still has to spend millions digging up the street to lay thicker wires.
Which leads directly to the second pillar, incentives. Because look, if the utility only offers me pennies, I am not risking my morning commute for the grid. Range anxiety is a powerful psychological barrier.
Exactly. The utility has to offer payments high enough to overcome that fear. The Texas example of giving the driver 90% of the revenue is a massive incentive. But that triggers the third and arguably most difficult pillar.
Which is?
The program's total costs must remain low enough that it actually benefits all ratepayers.
Right, because if the utility is paying me thousands of dollars a year to drain my car battery,
Yeah.
doesn't that just raise the baseline electric bill for the family down the street who doesn't even own an EV?
That is the central regulatory nightmare the CPUC is trying to solve right now. If the utility overpays the EV owners, everyday ratepayers end up subsidizing the wealthy early adopters.
Nobody wants that.
No. So the solution lies in designing revenue-neutral rates combined with strict automated parameters.
How does that work in practice?
You, the driver, open an app and set an unbreakable rule. Something like, my car must be at least 80% full by 7:00 a.m. no matter what.
Okay, so I have total peace of mind that I can get to work.
Exactly. The AI takes over from there. It might drain your car down to 40% at 6:00 a.m. to help the neighborhood avoid a blackout, and the utility credits your account for that power. But then, at 2 a.m., when wind power is surging on the grid and electricity is practically free, the system buys that cheap power to fill you back up to your required 80% by morning.
That is brilliant.
You get a lower monthly power bill. The grid survives the 6 p.m. spike without needing a $32 billion upgrade, and the non-EV drivers don't see their rates explode because it's revenue neutral.
The elegance of that system is incredible when all the pieces finally talk to each other. Let's sort of synthesize the journey we just took here. We started with a heavy-handed federal mandate from the DOT to force the rapid manufacturing of 100% American-made 350-kilowatt chargers.
Yeah.
Then we uncovered a $32 billion infrastructure challenge because delivering that massive power creates destructive rebound peaks on local transformers. We looked at how dynamic load balancing and charging as a service use AI to act as a hyper-intelligent traffic cop. And we ended with the realization that V2G is turning millions of driveways into highly lucrative virtual power plants.
It's a lot to take in. But whether you are prepping for a boardroom meeting on energy investments, or you are simply looking at your own electric bill wondering why it is so high, this shift fundamentally alters your relationship with the machine parked outside.
It really does.
A vehicle is no longer just transportation. It is becoming interactive energy infrastructure.
It makes you look at a regular parking lot in a completely different way.
It absolutely does. And, this evolution raises a profound question, something bubbling right beneath the surface of all the data we reviewed today. For over a century, the power dynamic in energy has been completely one-sided. Massive, centralized utility monopolies generated the power, and everyday citizens had absolutely no choice but to buy it at whatever rate was dictated to them.
Right. We've just been passive consumers at the end of the wire.
But If millions of everyday drivers are soon going to own the massive bidirectional batteries that are literally keeping the national grid afloat during peak hours, I mean, do we eventually see a future where individual citizens acting collectively through software have more leverage over the price of electricity than the century-old utility monopolies do?
Wow, think about that the next time you look out the window at your driveway. You might not just be looking at a car, you might be looking at your own personal leverage against the grid. Thanks for joining us on this deep dive.